Exponential functions, general form, growth, and decay. An exponential function is a function where the independent variable x is an exponent. The general form of exponential functions is f of x is equal to a times b to the x. Now, in this equation, a must not equal 0. If a did equal 0, then this entire thing would be 0, and it wouldn't be exponential. It would be a horizontal line where y equals 0. And in this situation, a represents the y-intercept. And we'll see why that is in just a bit. b, so here our b value, b has to be greater than 0, and b can not equal 1. If b did equal 1, then no matter what we put in for x, 1 to any value is 1. So this would all be 1 times a. And again, we just have a horizontal line, but this time where y is equal to a. b is known as the base value, or the multiplier. And it's really nice to see in the table the multiplier and how it comes into play. When blank, the function will grow exponentially. When b is greater than 1, the function will grow exponentially. The most basic exponential function is f of x is equal to 2 to the x. We're going to graph that function now and make a table. So in this situation, it's important to note that the a value is 1. And so we know that our y-intercept must be 1, because the a value is the y-intercept. Because our b value is 2, the multiplier is 2, from this point, when we move to the right 1 unit, we have to multiply our y value at this point by 2. Our y value is 1, so we multiply it by 2. So our y value here must be 2. And again, when we move to the right 1 unit, we take this y value and we multiply by 2. There, the y value is 2. So 1 unit to the right, our y value must be 4. Move 1 unit to the right, multiply this y value by 2. The y value is 4, so there it must be 8. Move 1 unit to the right, multiply by 2. 2 times 8 is 16. And right there is our next point. As we move to the left, we divide this y value by 2. So it's got to be 1/2. And then it's going to get closer and closer to the x-axis, and it's really just going to hug right up against the x-axis. And we can see that this is going to come up. It's going to have this nice curved shape to it, like that. And it'll go on and on in that direction. And later on we'll talk about it, but this is called an asymptote. And the asymptote is the place that the function never touches. It gets really close to it. Now the table here we can fill out. When x is -1, we can see that the y value is 1/2. When x is 0, remember our A value here was 1, so we have 1. When x is 1, our y value was 2. When x was 2, our y value was 3. When x was, whoops, not 3, that's 4. When x was 3, our y value was 8. And when x was 4, our y value was 16. So if we look at our graph or our function here, we have 1 times our 2. So in our graph, we can see there's our y-intercept, and here's our y-intercept in the table. And then our b value, our 2, we can see in the table as x increases by 1. So as x increases by 1, let's just put that in. Our x value is increasing by 1, and that has to stay consistent in order for this pattern to follow. Our y value multiplies by 2, and that just continues. That's why the b is called the multiplier. Our b value here is called the multiplier. Okay, so, and we can see the multiplier in the table, or in, excuse me, in the graph. As we move 1 unit to the right, when our delta x equals 1, we multiply our delta y by 2, as we had talked about before. So you can see the parts of the equation show up in the graph and in the table. In this situation, when blank, the function will decay exponentially. Well, when b is, well, we saw above that b had to be greater than 0. So in this case, b has to be between 0 and 1. When b is between 0 and 1, the function will decay exponentially. And so we're going to have a look at a situation like that now. So our a is 8, so we know that our y-intercept is 8. Because our b value here is 1/4, when we move to the right 1 unit, we multiply this value by 1/4. So 8 times 1/4 is 2. And then, I should put that in black really, is 2. And then again, when we move to the right 1 unit, we multiply 2 by 1/4, which is 1/2. And so this is going to get really close to the y-axis very quickly. When we move to the, the x-axis, when we move to the left 1 unit, we have to take this y value and multiply by 4. 8 times 4 is 32, so this is going to go up really fast, and it's going to be off of the grid right away. So about like that. All right, so in our table, we had when x was -1, well, we take this y value of 8, multiply by 4, and it's got to be 32. When x was 0, we had a y value of 8. We can see that right there. When x was 1, let's just increase by 1 in each of these. So our multiplier here, we can see we multiply by 1/4. It's really the same as dividing by 4. And so if we maintain that pattern, this is going to be 2.5. Really, it's easier as a fraction, 1/2. Now, dividing by 4 is 1/8. Dividing by 4 is 1/32. And that is the exponential functions, general form, growth, and decay.